All right. So in our question number 1, we are told that in 2021, 80 candidates were randomly selected in a survey to provide information about expenses incurred by students during the preparation for examinations for the Institute of Certified Public Accountants, Uganda, in order to guide future students in the basic requirements. On the basic requirements, the frequency table below shows the expenditure in dollars from the participants. So they give us the expenditure in dollars and the number of candidates, 100 to 150, 150 to 170, 170 to 200, that's a 10, 200 to 220, that's a 24, 220 to 250, that's a 12, 250 to 270, that's a 7, 270 to 300, that is a 6. We are required, among other things, to calculate the geometric mean for the candidates. So we shall start from there. There is something that is typical here when it comes to the class limits. When you look at the class limits, this is 100 to 50, which is a width of about how much? 100 to 150. What's the difference there? That's a difference of 50. Then we have 150 to 170. That's a difference of how much? That is a width of how much? Of 20. Then 170 to 200. That's a difference of how much? 30. And then 200 to 220. That's a difference of 20. Then this is a difference of 30. Difference of 20. And this one is about how much? 270 to 300 is about how much? That's 30. So you can see these are unequal class size. The class sizes are not equal, which is usually expected to be the case. So the first thing you're going to do in the exam is to check out the class size. Is it equal? Because usually it's the same. So if it is not equal, then you have to think about what we call the frequency density. You know that is the direction that you're going to take. Frequency density. And that's going to be applied in number 3. Number 3, histogram, which we use to determine the mode. So this is what is happening in these kinds of questions. It's a new trend, and you must be very, very careful. But before we go into issues of frequency density, which is our second segment, we are beginning with the geometric mean. So the question is, how do we actually calculate the geometric mean? What is the formula for the geometric mean? Now, the geometric mean that we are looking at here is geometric mean of group T data. The geometric mean can be for grouped and ungrouped T data. So we are going to look at both of them. Geometric mean of grouped data, geometric mean of ungrouped data. So the geometric mean for the candidates that we are talking about in our question, the 80 candidates, can be calculated using this very nice formula here. Yes, it's not a guarantee that the formula will be provided to you, but on a good day, it might be provided to you. So we are assuming you're not going to be given. The geometric mean of grouped data is given by this formula, antilog, summation of f log x, grouped data should also indicate that. Antilog of whatever is in the brackets here, summation f log x over summation of f. What am I going to look for? I have to look for log of x. I have to look for the antilog. So what do? I present this in a tabular kind of table. Okay, tabular form. So in that way, I have my table well laid out, showing the expenditure, showing this is supposed to be expenditure. Okay, showing the expenditure and the frequency. I think my frequency will be a small f to make it comply with our formula. And now I will need, for purposes of determining the geometric mean, I will need the log of x. I will need the log of x, and then f log of x. You see that? I need the log of x, f log of x. So I am going to, oh, what have I spoiled? I want my table to look nice. I don't like that kind of table. So as I'm doing this, someone is going to list for me the logs. Just list them in the chart. Let's take off some minutes. We get the log of x. Okay. Log of x. Then you list them in the chart. Just get your calculator. I need the x first of all, sorry. I'll start with the x. I'll start with the x. I need the x. I need the x. Yeah. I need the x. So that I can determine log of x, not so. Yeah. I need the x first. So I'm going to change it to something here a little bit to make it look nice. Okay. Don't worry about this. I'll just put out this here. Like that. Just using some other, working I've had before. So I don't want you to think that this is part of the it's not 18. Someone is giving me some correction here. Thank you so much. I need to change that as well. So since you are the volunteer of the day, I'm going to ask you to unmute and tell us. Just a minute. I want to get these. I want to get these things here. Where do you find the Nanjara? You have to get someone there. How do we get? I will send you something for you to look at. Otherwise, that one will take us. Just get on your calculator. Think you can press what? This thing is overteasing me. Okay, anybody got to give us the X values? Anybody to give us the X right away without us struggling? The X, the X, the X, the X. Anybody? Give us the X. Just list the X values quickly here. So I think I have my column for X and then log of X and then F log of X. X, I don't need something big, just something small is enough for me. So that size is okay. So we need the X basing on the structure of the formula. We shall need the X here. That is my X. X, then log of X, then F log of X. Okay, so later on, unmute yourself. You read for us your X. Leighton, are you there? Unmute. The first one is how much?
125.
125. And the next one?
160.
160. Then the next one?
185.
185. You're doing well. Let's continue.
210.
210. Then the next one?
235.
235. Then the next one?
260.
260. Perfect. Then the last one?
285.
285. So which one were you talking about that's not correct? I have 5,
The 18.
8.
The 18.
The 18, eh?
Yes.
The 18 is supposed to be what?
In the
This
question
one
table,
supposed to be
it's
what?
showing 10.
Ah, okay. You see, your eyes are sharper than mine. You are sharper. So this is 10. Like that, eh?
Yes.
Good. First of all, before we go to anything else later on, can you guide someone how to get the X? In case someone does not know how to get the X. So how did you get those figures?
I get the higher boundary plus the lower boundary, then divide by 2.
Higher boundary plus the lower boundary divided by 2. Good. And then can you guide someone on how to get log of X? Is it automatic on the calculator? Log of X? There is log and X, not so. You press log, then the figure. Could I be right? This is not the density. Someone is asking, is the density? No, that's not the density, my sister. This is X, class mark. X is the class mark. Where, let me define, where X is the class mark. And then F is the frequency. We are not yet on the frequency density. So how do we get X? For example, as our colleague has mentioned, for the first class, for the class 100 to 150, the X would be 100 plus 150 divided by 2, which gives us the 125 that we have right here. Okay, now let's go to the log. Later on again, let us just give us the first log value in the interest of time, so that we don't sit here the whole day. In the interest of time, give us the log of X. Please unmute yourself.
Yes, the first one, I have 2.097.
2.097. Then the second one. By the way, these ones you have to go to 4 decimal places. 4 decimal places. Okay. That is our standard. The
Okay.
institute. Yes. So give me 4 of them.
2.0969.
2.0969. The second one?
The second one, 2.2041.
Good. Then the next one?
The next one, 2.2671. 2672.
2672. Good. Then the next one?
The next one, 2.3222.
Good. Then the next one?
The next one, 2.3710.
Good. Then the next one?
The next one, 2.414. 2.4150.
Okay. And the last one?
The last one is 2.4548.
Good. So now we have the log of X. We are going to multiply the log of X and the 5. The log of X and the 8. So that's the frequency. Log of X times the frequency. This times that. Okay, let us go ahead. The first one. The first one. Don't give up on us, Dayton. Don't give up on us.
The
Don't
first
give
one.
up on us. The first one.
The first one is 10.4845.
10.4845. Then the next one.
The next one. The next one is 17.6328.
Then the next one.
Then the next one is 22.672.
Layton, I disagree, even if I'm blind. Give us another one. Oh, you said what? 20 what?
It's the
It
one.
can't be. It is the
Yes,
one.
yes.
Ah,
This is
okay.
10. You
It
changed it
is
from
10.
18.
10 times, okay. 20 what? 22.
22.672.
Oh, I think the mistake is in the mistake is on the question. This one is supposed to be 18, eh? The mistake is on the question
Oh,
itself. Yeah.
okay.
So we shall change the question. Let me go there and change before people ask me, is that another question? You may think it's another question. We are changing this from 10 to 18. The mistake is here. 10 to 18. Good. So if that is 18, give me the new figure. You can give me the new figure.
It is
If that
40.
is
40.8096.
8096. Then the next one.
Next one is 55.7328.
Then the next one.
The next one is 28.4532.
And then the next one.
The next one is 16.905.
And then the last one.
The last one is 14.7288.
So that gives us summation f log of x, the total. How much? So let all of us now add, not only Layton. Let all of us add up and you share in the chat. We share in the chat. I can see 184 from Shadrach, 184.7457. Perfect. 184.7457. So with that, we are now in position to determine our geometric mean. So we pull out the formula from the previous slide, and we say, therefore, our geometric mean is equal to, remember we had antilog, summation f log of x over summation of f. Of course, by now, you must have added through our summation of f just here, where we have the f values, summation of f, and that's why I was saying it is 18, because they talked about 80 students. So there were 80 talked about in the question, summation of f. So I substitute geometric mean, that's going to be anti-log 184.7457 divided by 80. So now you can use your calculators and tell me what you're getting as our geometric mean. So what is our geometric mean? 2. Okay, so the dollars here being given 2.3093. Oh, antilog antilog 2.3093. Therefore, the final answer comes to how much? I'll fit it here. How many dollars? The final answer. Shift log, you put in 2.3093. Antlog, you shift. There's a shift button on your calculator. Shift antilog 2.3093, bringing us to about how much? Bringing us to 203.8608. Perfect. So that is our geometric mean for grouped data. Next, we are going to look at geometric mean for ungrouped data. But before we go there, I'll give you 5 minutes to put down your table, look at the figures. If you have any questions, you raise them, and then we go to the next segment.